not critically threatening. We'll continue to monitor these systems and provide updates as needed. Ever wonder how a tropical cyclone maintains its strength when it moves over land? We call it the brown ocean effect. Usually, tropical cyclones weaken rapidly over land because they are cut off from their primary energy source, the warm ocean waters. However, if the land is unusually moist, like after a period of heavy rainfall, the storm can tap into that moisture. The saturated soil evaporates, providing the storm with a new source of heat and moisture, almost like a mini ocean on land. This allows the storm to maintain or even intensify its strength further inland than one might expect. We are watching several tropical cyclones in the western Pacific right now, including Tropical Storm Krasa or 12W, and it's important to consider the land conditions they may encounter. The brown ocean effect can significantly impact the storm's behavior and the potential for inland flooding. It is a fascinating example of how land and atmospheric processes interact. Currently, the global tropical cyclone risk activity score is being driven primarily by activity in the Western Pacific. Tropical storm Krasa, or 12W, is the largest contributor. Let's compare it to Invest 91W, which has a much smaller, but still non-negligible contribution. Krasa is a tropical storm with sustained winds of 45 knots and a pressure of 997 millibars, located at 17.7 north, 143.4 east. In contrast, Invest 91W is a tropical disturbance with 15-knot winds and a pressure of 1000 millibars, situated further north at 27.8 north, 132.6 east. The environment surrounding Krasa appears more conducive for intensification, with warmer sea surface temperatures and lower wind shear. Invest 91W, being further north, is in a less favorable environment. Forecast tracks suggest Krasa will continue generally northwestward, potentially posing a risk to land areas in the coming days. Invest 91W's future is less certain, but it poses a lower immediate threat due to its weaker intensity and less organized structure. Therefore, Krasa is currently the higher concern of the two systems. Let's focus on Tropical Storm Krasa, which is 12W, in the Western Pacific. Krasa is currently contributing 2.02 points to the global tropical cyclone risk activity score of 4.88. This contribution is significant because, as a named storm, it has the potential to intensify and affect populated areas or shipping lanes more directly than a weaker system might. As of the latest update, Krasa is located near 17.7 degrees north and 143.4 degrees east. That places it well out in the open waters of the Western Pacific. The storm has sustained winds of 45 knots and a central pressure of 997 millibars. Both the wind speed and pressure have remained steady recently, indicating a pause in its intensification trend. Krasa is moving generally to the north. Steering factors include the subtropical ridge to its east, which is helping to guide it northward. Looking ahead, environmental conditions around Krasa are moderately favorable. Sea surface temperatures are warm enough to support intensification, but there is some moderate wind shear that could inhibit rapid development. The level of moisture in the surrounding atmosphere is adequate, which is conducive for maintaining its current intensity. However, any increase in wind shear could disrupt its structure. Given its current track and intensity, continued monitoring is essential, especially for those in or planning to enter Western Pacific shipping lanes. The global tropical cyclone risk/activity score is currently 4.88, which puts us at a low alert level. This indicates that we have one or more weak to moderate systems active, requiring monitoring but not posing any immediate major threat. There are currently 5 active systems across the globe. The largest contributor to the risk score is Tropical Storm Krasa, or 12W, located in the Western Pacific. It's maintaining winds of 45 miles per hour. Those in shipping lanes should continue to monitor its progress as it moves generally to the north. Next is Tropical Depression Francisco, or 10W, also in the Western Pacific. It has sustained winds of 25 miles per hour, and a pressure of 993 millibars. Tropical Depression Come, or 11W, continues to track through the Western Pacific. It is packing winds of 30 miles per hour with a pressure of 997 millibars. We're also watching two disturbances, 97E in the eastern Pacific. It remains a low-pressure system with winds of 25 miles per hour. Additionally, 91W in the western Pacific is being monitored as a tropical disturbance with 15 miles per hour winds. Overall, while global tropical activity is present, it's not critically threatening at the moment. We'll continue to monitor these systems closely and provide updates as needed. The current tropical cyclone risk/activity score is 5.57, which puts us at a low alert level. This indicates that we have one or more weak to moderate systems active globally. While there's no immediate widespread threat, these systems bear watching. We currently have 5 active systems around the world. Leading the way in terms of risk contribution is Tropical Storm Krasa, 12W, located in the West Pacific. Krasa is packing sustained winds of 45 miles per hour. Close behind in risk is Tropical Depression Kome, 11W, also in the West Pacific. It has sustained winds of 30 miles per hour. The next highest contributor to the global risk score is Tropical Depression Francisco, 10W, with winds of 25 miles per hour. Also contributing to the total risk is Invest 97E in the Eastern Pacific. This is a low-level system. Finally, we're monitoring Invest 91W, a tropical disturbance in the West Pacific. Overall, the global pattern shows activity primarily focused in the West Pacific, with a few other areas under observation. Currently, the global tropical cyclone risk/activity score is being primarily influenced by 2 systems, Tropical Depression Francisco, designated 10W, and an Eastern Pacific low-pressure system currently labeled as an Invest, 97E. Francisco, located at 26.3 degrees north, 121 degrees east, is a tropical depression with sustained winds of 25 knots and a central pressure of 993 millibars. 97E is positioned at 10.7 degrees north, 139.7 degrees west, also has winds of 25 knots but a significantly higher pressure of 1008 millibars, characteristic of a less organized system. The environmental conditions surrounding 97E appear more conducive for intensification due to warmer sea surface temperatures and lower wind shear in the eastern Pacific. Francisco, while already a tropical depression, is in a less favorable environment that may inhibit rapid development. In terms of potential risk, 97E poses a greater long-term threat. Its projected track suggests a potential impact on the Hawaiian Islands, while Francisco is expected to remain offshore, posing less direct risk to populated land masses. Therefore, 97E warrants closer monitoring for potential intensification and trajectory shifts. The current tropical cyclone risk/activity score is 5.57, which puts us at a low alert level. This indicates that we have one or more weak to moderate systems active globally. While there's no immediate widespread threat, these systems bear watching. We currently have 5 active systems around the world. Leading the way in terms of risk contribution is Tropical Storm Krasa, 12W, located in the West Pacific. Krasa is packing sustained winds of 45 miles per hour. Close behind in risk is Tropical Depression Kome, 11W, also in the West Pacific. It has sustained winds of 30 miles per hour. The next highest contributor to the global risk score is Tropical Depression Francisco, 10W, with winds of 25 miles per hour. Also contributing to the total risk is Invest 97E in the Eastern Pacific. This is a low-level system. Finally, we're monitoring Invest 91W, a tropical disturbance in the West Pacific. Overall, the global pattern shows activity primarily focused in the West Pacific, with a few other areas under observation. Ever wonder how we try to predict the paths of storms like 10E, Francisco, or 12W, cross up? It all comes down to weather prediction models. These aren't crystal balls, but sophisticated computer programs. They ingest vast amounts of data, temperature, pressure, wind speed, and use complex equations to simulate the atmosphere's behavior. However, the atmosphere is a chaotic system. Small errors in the initial data can grow and lead to different forecasts. That's why you often see a range of possible tracks for a storm, representing the uncertainty in the models. So, while models are incredibly useful, remember they are just tools, and understanding their limitations is key to interpreting the forecast.